Alright, this is part 2 of the virtual machine installation process. And what I'm doing right now is I'm running the virtual machine, and this is a continuation of the previous step. Instead of running a virtual machine inside the virtual machine, I'm just running a virtual machine. I also have to remind you that the command that you have to use is a little bit longer than what we had last time, because I forgot one thing when I specified that. So let me show you the actual command that you need to run it. I'm putting an editor here so you can see it. The command is kvm-cd-rom, and in your case you want to specify device SDB1, or whichever device has the live image, and then you specify HDA, and then in the previous case I cannot remember what I used. I think it's disk.img.raw as the file name of the image file. And then you have to specify one more thing to make it work. You have to specify dash boot D, which basically means I want to boot from the CD-ROM and not from the hard drive, because the hard drive is blank at this point. So we want to make sure that we start, with the CD-ROM, and that's what the boot D is for. If you want to control and specify how much RAM is allocated, you can do that too. And let's see here. I'm using another window to look at that information. So to specify the amount of RAM, you specify in order to do that, I think the default is going to be fine, so you don't need to do that. So this is the command that you need to run the virtual machine. Okay, so I'm getting that out of the way. And because you're using the same live image, but this time you want to run the installer, so you just select the installer to run the installer. And when you run the installer, it will get you to the text screen that we were kind of stuck at last time, except this time, because we are only one virtual machine layer down, it'll be much faster than last time. So I'm just pressing the enter key to take the default of the first 4 options. And we will change the host name to VM1, just as last time. Domain name is empty. Just press the enter key to continue. Debian archive is United States. We'll pick the first archive mirror, so just so that we do not have to deal with that as a potential issue. And this time it should run quite a bit faster. Yep, it's a whole lot faster than last time. And now what the installer is doing is actually downloading additional packages that we need in order to finish the installation. This is a really cool process, because you know that you will be getting the most up-to-date modules and packages when you install the operating system. And many of these are, this is a NIC module, so it's actually trying to download additional modules so that we can properly talk to the hardware of the machine. But in this case, since it's a virtual machine, the devices are very simple. We can select it to be fairly simple. And part man is a partition manager. We'll get to that part later on in the installation process. Alright, now it's asking you for the root password. I just wanted to be consistent with the live image, so that we don't have to remember all these passwords. But in a real system, you definitely don't want to use a simple password like ball for root. Okay, so in this case I'm just doing that just so that I can remember that. Okay, and we have to specify one regular user, so I'm just going to use my own name for that and use TAUYEUNG as the user for that account, and specify a password for the regular user, and then we specify the time zone. And now it will take a little bit of time because it's going to download the kernel image and a whole bunch of stuff here. I take it back. This step doesn't take as long because we are actually trying to install. We're trying to partition the disk at this point. Okay, so here we have several options. The first option is to use the entire disk as one single partition, which is okay for a laptop computer or a desktop computer, but for a server that may not give you the best flexibility. The second one, let you use LVM as an intermediate layer between the file systems and the actual physical disk. With this option, what you can do later on is you can change, or you can add a drive and you can change the partitions so that a single partition can span over multiple drives, and you can expand partitions that way. It's a much more flexible way to do things. The third option, let you set up the entire disk, and this time you use encrypted LVM. Encrypted LVM means almost the entire drive, except for the boot partition, is going to be encrypted. That means every time you start your computer, somebody has to be there to type in the password to decrypt, to let the system decrypt the content of the drive. It's more secure, but that also means that you cannot have a remote restart because it will ask you for the password in order to boot the system. The last option is manual, which means okay, everything is up to you, and you can decide how you want to set it up. So for the purpose of this demonstration, let's go ahead and select manual, because we want to make things as hard as we can, right? So at this point, we can deal with one of these items here. We cannot really deal with software RAID because we only have one single drive in this particular virtual machine. But we can set up logical volume manager. We can do that. But before we do anything else, let's go ahead and deallocate the primary partition here, because we are going to use our own way of partitioning this hard drive. So we'll go ahead and delete the partition. And now we have 4 gigabytes of free space. Now, when you set up, when you use LVM, LVM has one little problem. You cannot boot to a LVM partition. So what we need to do is we have to take up some space here, create a new partition, and the new partition size doesn't have to be big because we just need to put all the files that we need to bootstrap the system into this partition. Typically, even 20 megabytes is enough, but I will go ahead and allocate 100 megabytes. And then we specify 100 megabytes and click enter, and we'll make it the first primary partition. And the mount point is also important in this case. We want extension 3, that's good. We want the mount point not to be root. We want the mount point to be /boot in this case. Because this is a very important partition. Every file that we need in order to bootstrap the system has to be here. Because that's before LVM, the LVM driver takes into effect. Everything else here looks good. We'll change the bootable flag to on, because it is the boot partition, and done setting up the partition. So that part is done. So now we have, a large amount of free space here, and we'll use up the entire free space, as one single LVM partition. So we'll go ahead and create a new partition, and we'll use up the entire space, and we'll make it a primary partition too, because you can use up to 4 primary partitions. Now this is important because we want to use LVM. We don't want it to be extension 3 anymore. We want it to be an LVM partition. So you press that, and then you go find physical volume for LVM. That's what we need to select. If you want encryption, this is what you want. But since we don't want encryption on a server, like this, so we'll just go ahead and pick LVM. Encryption is good if you are dealing with a portable device, such as a laptop computer, a notebook computer, or a tablet. That would be useful because if someone gets physical possession of the device, this means that person cannot get to the data of the device unless that person also has the key to unlock the content. Now, when you're talking about a server that is up most of the time, the attack is not going to be someone getting physical access to the system. The attack is going to come from the network, when the file systems are all mounted, and which means the encryption is not going to give you any protection. So that's why for servers, you want to select, LVM in this case. And then we'll press the enter key. And everything is good at this point. Physical volume for LVM. And then we'll go ahead and say done setting up the partition. And then we'll go back here and say configure the logical volume manager. But before we perform that step, it says we have to write all the changes back to the system. And then we select yes. There we go. So now we are in the LVM configuration screen, and let me just show you what we are seeing here on the screen. It shows us that there's one free physical volume, and what a physical volume is basically, as the name implies, you can have physical volumes from multiple drives, and use that to make up one single logical volume group. So that means your logical volumes can spread over multiple actual physical devices. The next thing we want to do is to create a volume group. A volume group is a logical entity that can span over multiple physical volumes. So this is an abstraction layer, so that we can see a single entity that is actually implemented by multiple physical devices. So we click create volume group. I'm not very imaginative, so we'll just use VG0 to represent volume group 0, which is the only one that we're going to create here. And then we press continue. Now it's asking you what devices do we want to use for this volume group. Well, we only really should have one choice, which is SDA2. Because SDA1 is our boot partition already, and we don't want to mess with that. Alright, so now we have just used up the only physical volume for this volume group, and you can attach additional physical volumes to this volume group when you mount a second and a third hard drive. But at this point, since we only have one single hard drive, we are done with this step. So the next thing we want to do is to create logical volumes. Okay, we're going to have to create multiple of these things. And since we only have one single volume group, that's our only choice. If you had created multiple volume groups, then you can actually select which one we want to use in this case. Alright, now this part is kind of important because we want to separate different portions of the file system as independent volumes. Okay, and what I'm doing here you cannot see this because I'm doing it inside a window that you cannot see, is I'm going to look at how I use up the different volumes with my regular setup. So we'll go ahead and set up one for root here. Okay, so this is the volume group. Excuse me, the logical volume has a name of root, and this is going to be the root of the entire file system. Now, I think you might think that we need a lot of space for that, but that's not really the case, because not too many big files should be stored in the root volume or the root mount point, and I'll explain that along the way. So we'll pick this as our name, and we can now select how big do we want that volume to be, and we'll go ahead and start small, because with the good thing about logical volume management is we can change the sizes of these logical volumes later on. I mean, we can shrink it, we can expand it, we can do all kinds of stuff like that. So we'll go ahead and just specify let's just say 200 megabytes for that. We can come back and change that later. Okay. And we also want to create some more. Okay, we have one logical volume right now. So we'll go ahead and create a second volume. Create a second logical volume. And we have to allocate from the volume group VG0. Press the Enter key. And this time we have home. Now the home logical volume, as the name implies, is going to be mapped to /home in the file system. This can, depending on what kind of server you are setting up, this can take up a lot of space or not a whole lot of space. For instance, if you're setting up something as a web server that allows individual users to expose content to the HTTP server, then you can potentially be talking about gigabytes and gigabytes and gigabytes of data. On the other hand, if you have a server that is let's say a MySQL server or a database server, the data is not going to be stored in the home directories, so you can go with a very minimal home directory setup. So in this case, we'll just make that assumption and just say that the home directory does not need a whole lot of space, and we'll just go ahead and allocate, let's say 50 megabytes to the home logical volume. Okay, so that's our second one. We'll go ahead and create some more. Let's go ahead and this time create the logical volume to store all the operating system and application files, and we'll call it user USR. And then we press the continue key, and we have to specify the size here. Now this part can be very big, it can also be very small, depending on how you want to use the system. A desktop system can take up a lot of space in USR, because I can install a lot of different types of application programs on the desktop. A server, on the other hand, typically does not have as much applications to install, and you can probably get away with, let's say 500 megabytes, half a gig. And remember, we can change all this later on. So this is just we just have to make sure this is enough for the initial setup. And after that, if we run out of space, we can always expand that. So you click continue, and we'll create some more create another logical volume, and this time we'll create var, VAR. Now var or /var in the directory tree is responsible to store just about anything, any data that does not relate to home, does not relate to specific end users. So that means if you try to implement, let's say, a database server, the database data will be stored somewhere in the /var directory tree. If you try to run Apache, the home page, not the home page, the default pages will also be stored in /var. If you try to run a print server, the spool files will be in /var. If you try to run an email server, all the email messages that are queued to go out and all the messages that are received will also be stored in /var. So you can see that with a desktop computer, /var does not have to be too big, but with a server that can potentially you can potentially have some demand in the /var partition. But initially it does not need to be too big, so we'll go ahead and allocate 500 megabytes or half a gig to it. Alright, so now we have 4 logical volumes created. Let's go ahead and create some more. Some people like to allocate one partition for the temp folder or /temp in the directory tree, so we'll go ahead and create one. And this one also depends on what you want to do with the server. Some web pages, particularly PHP, will try to store a lot of stuff in /temp. It's generally speaking not a very good idea to put that much stuff in /temp, so we'll make this a little bit smaller, and let's say 200 megabytes. We'll create, let's see here, we have user, home, var, root, temp. That's about all the usual volumes that you have to set up for a server. So we can set up additional ones later on. I mean, you can definitely move stuff around later on, but this will be enough at this point. So we'll go ahead and say finish. And now the display looks a lot more complicated than last time, because all the logical volumes are now entries here that we can actually edit. So we'll go ahead and specify this particular logical volume will map to home, and it will be formatted as extension 3. So we'll go ahead and press the enter key so we can specify the details. So we'll use it as extension 3, and the mount point is going to be /home. So we'll go ahead and specify /home user home directories. We'll take all the defaults, and then we are done setting up this partition, and then we move on to the next one. The next one is for root, or basically / of the file system. So once again, we press the enter key. We'll use it as an extension 3 file system, and then the mount point is going to be a single /, the root file system. And we'll take all the defaults, specify done setting up the partition, move on to the next one. The next one is temp. So we'll use it as an extension 3 file system, and specify the mount point to be /temp. And then we say done setting up the partition. So you can see this part here is quite tedious, but it does give you a lot of options. There's a lot of flexibility, as far as the installer is concerned. Okay, the next one is user. So we'll specify that, and we'll format that as an extension 3 file system, and specify the mount point to be /usr static data. Basically programs, mostly programs, man pages, and stuff like that. And we are done setting up this partition. Moving on to /var. We'll use it as extension 3 again, and specify the mount point to be /var, like so. And then we say done setting up the partition. I believe that's all that we have, because the next one is an actual partition, which is /boot. So we are done setting up here. So you scroll all the way down, and then you specify finish partitioning and write changes to disk. This might take a while, depending on how much space you allocate, because it's actually going ahead to make all the changes that we have specified so far. This question asks, do you want to return to the partitioning menu? Oh, we haven't selected anything as for swap space. Let's go back and specify swap space here. I don't really have any space in the primary partition, so we have to go back to the logical volume manager and add a swap partition there. Now this is kind of cool because now we can actually change the size of the swap partition more dynamically. Before the logical volume manager can be configured, the current partitioning scheme has to be written to disk. These changes cannot be undone. So let's go ahead and create all of those logical volumes. It doesn't take too long here because we have tiny logical volumes, so the formatting of those volumes doesn't take up much time. So we'll go ahead and create another logical volume for the swap partition. So we'll call that swap, and we can specify a particular size. I'm not going to run anything that will actually need to use the swap partition, so the size of this really does not matter. I'll just specify 256 megabytes. On the real server, on the other hand, this can be quite important, depending on what you're using. Anytime you have to use a swap partition, anytime you're using more memory than physically is installed, in a server setting, that's definitely not a good situation. You should be able to run everything from RAM. And we are all done here. So we'll page down and go to finish partitioning and write changes to disk. And that warning message from before should be gone because now we do have oh, okay, never mind, I was wrong, because even though I allocated a logical volume for swap space, I did not declare that as swap space, so that's why it's still complaining about that. So we'll have to find out where it is. It's right here. It's a logical volume swap, but I have not told the system what it is for, so that's why I have to click here, press the enter key, and then we'll specify use as swap partitions or swap area, and that's it. Okay, we'll go ahead and say done setting up the partition. Back to this screen, page down, go all the way to the bottom part here, and then specify finish partitioning and write changes to disk. You can see that the installer is actually quite smart. It tries to detect problems like not having a swap partition and stuff like that before it proceeds to actually do it. Alright, so we are getting this message here, which is a general warning, and it'll tell us what we want to do or what is going to be done in this round. So we'll go ahead and commit the changes. And now it's installing the base system. When it's installing the base system, it's actually going to the remote server that contains all the files. So it's installing it from a remote repository in this case. And the speed of this depends a lot on your network speed, as well as how quickly it can go out to the repository and actually get the files. We have had some issues in the past in the lab, particularly in room 152 section D, and the speed can change dramatically. Sometimes it's really fast, and other times it's very slow. So when we do this in the lab, a good portion of that depends on the connection speed to the internet. And because we are doing this inside the virtual machine, I think the network speed of the virtual machine to the host environment is only a 10 megabit per second connection, and that partially limits how fast we can do the installation inside the virtual machine. And you will encounter this problem too when you do this inside the live image environment. And this is also, when this is a situation where an HTTP proxy is going to be useful, because let's say the class with 21 students we are all doing this step here. Without a proxy server, each instance is actually making a connection to the outside world, going to the mirror that is sitting somewhere else and try to pull that file. Now that's not very smart, because all 21 students in this class are going to get exactly the same files. So having multiple connections to download the same file 21 times is not a good use of network bandwidth. But that's the way it is without a proxy server. Now on the other hand, if there's a proxy server, then we can configure the installer to talk to the proxy server in order to make connections to the internet to get files. Of the many things that a proxy server can do, one of the things that it can do is caching, which basically means once, let's say I'm the first one to to start this process. So with a proxy server, with a caching proxy server, what that means is once I get the files that I need, all of those files, or a good portion of that, should be cached on the proxy server. So if you are the second person to go through this process, you don't have to go all the way out to the internet, because as soon as you get to the proxy server and say, hey, I want to get this file from that particular source, the proxy server will come back and say, hey, guess what? I have a local copy in my cache already, and then it will just serve, it will give you that file, it will transmit that file from its cache. And that's going to be a whole lot faster, because the proxy server is typically inside the local area network, and we don't need to rely on bandwidth connecting to the outside world once it is cached. So that's why it is a good idea in some situations to set up a proxy server for web traffic. So right now we have downloaded most of the files already, and it's just going through the configuration part to get things done. It takes a little bit of time, but it's not too bad. And once this step is done, we'll boot into the virtual machine, and that will be part 3 of the video clip, because I don't think I can, well, maybe I can, never mind. I can actually reboot without having to restart the virtual machine, because if I have to shut down the virtual machine, the next time I do the recording, I may not specify exactly the same area, and that's the problem. And that's why sometimes I have to chop it into multiple screen capture sessions. You can probably skip a few seconds and just check whether anything is interesting, because right now I'm just waiting for this process to be done. Holy moly, 1 minute and 12 seconds to download this file. Must be a kernel image file, because that's a single file that is quite big. We are 34 minutes into the second session, the second video clip. 34 minutes, sorry, not 34 seconds. When you do this, with the live image, it can potentially go faster, because I'm going through a Shure West connection here, and it's only good for about 20 megabytes per second. But the school actually has much better bandwidth connecting to the outside world. So even if 21 of you are doing the same thing, it can still be potentially faster than what you're seeing here when I'm running it from home. And we're just waiting here. There's nothing interesting going on. Alright, so finally we have something that's interesting. This is called a task selection process. Okay, so here's a default is no, we don't want to participate the survey, the popularity survey. So we just click no. And this is kind of useful. Okay, this is a screen that let you select not a single package, but a whole suite of package for a particular use. In other words, if you're setting up a desktop computer and you want a GUI, you just click here and it will pull in a lot of files. It will pull in a lot of files that relate to graphical desktop environments. If you want to run Apache as a web server, you can click this and it will just pull in all the packages that Debian thinks you will need in order to run a web server. So the same thing applies to SSH, mail server, and so on and so forth. Of all of these options, the only one that is actually useful is SSH server, because this allows you to remotely log into the virtual machine, which is going to be useful. So I'm going to click that option here, and then we use the tab key to go to continue, and then press the enter key. So other than SSH, we are only using a really basic setup here, and it should not take up a lot of space. By the time it's all done, I'll get into the server that we just set up and find out exactly how much space is used in each partition or in each file system. You can probably fast forward this part at least until the time is showing 1 second or 2 seconds. And then since it's only downloading the files, it still has to go through the process to unpack the files and then configure the files. So this will take a little bit of time. There we go. It's time to unpack the packages, and then it will configure those packages too. Alright, we are almost there. Okay, so the installation of the base system is pretty much done. The last thing it has to do is to configure the boot sector. Alright, so the new installation is the only operating system on this computer, so it should be perfectly safe to install the grub boot loader to the master boot record. Most servers are not going to be dual booting, so this should be perfectly safe when you're setting up a server. If you are setting up on a desktop computer or a laptop computer, you might want to pay some attention to that, because you can actually the installer is fully capable of setting up a dual booting system. Okay, so we're now all done. The installation is all done, and if we continue, it will actually boot to the new system. So we'll go ahead and press the enter key. It's now rebooting. So we'll see this original screen, and since I do not specify, okay, it's it's still booting into the live CD portion. So I'm gonna have to do this. Okay, send key, Control Alt Delete. What I'm doing is, this is called the monitor of QEMU, and what it allows you to do is you can do things in the back on the back end. And what I'm doing is I'm pretending that I'm pressing Control Alt Delete to the virtual machine, just so that I can restart and pick another option from the startup menu. But then I have to do it very quickly, because to get to this screen, you have to press Control Alt 2 in the virtual machine. To switch back to the normal screen, you have to type Control Alt 1. So I press the enter key, and then I have to quickly go back to Control Alt 1 to catch the BIOS setup screen. Or not. Oh. Okay, so now let's go back to here, press F. Doesn't give me an option. I might need to, okay, I'm gonna set up a third session, because I have to shut down QEMU, and there's no telling whether I can reposition the new virtual machine to this spot here. So I'm gonna have to shut it down first, and then do it all over again. Well,